Alright guys, today we are diving into parallelograms. We're going to be covering two sections in this set of notes and all the different characteristics of them. Alright, so to start off with, you need to know what a parallelogram is. And it is a quadrilateral. Quadrilateral, meaning a polygon with four sides, with both pairs of opposite sides parallel. So we're going to draw us a parallelogram and label it with these facts here. So we've got, it's like a slanted rectangle. And if you remember, the symbol for parallel are the little triangles or arrows. So those two sides are parallel, and these other sides are parallel. All right. Now then, a diagonal. I know y'all know what a diagonal is, but we're going to define it anyway. It connects opposite vertices. Connects opposite vertices. What are vertices? They are your angles. So, we're going to draw another parallelogram. And we are going to connect opposite vertices. That is your diagonal right there, and go ahead and fill in those dots. Okay, now parallelogram facts. We've got 5 different facts. The first one, both pairs of opposite sides are parallel. That being the exact definition of a parallelogram. So, okay, we're going to go ahead and draw a picture of that fact. Both pairs of opposite sides are parallel. Okay, the second fact, opposite sides are congruent. Opposite sides are congruent, and I'm using my congruent symbol for that. So we're going to draw the same parallelogram over again, and we're going to mark the sides congruent. Remember those little markings? Meaning congruent. We do 2 sides for these to show that those are congruent, and we do a single line for these to show that those 2 sides are congruent. Now then, the third fact, opposite angles are congruent. Opposite, I'm going to use my symbol for angles, are congruent. So we're going to draw our parallelogram, and we're going to show these acute angles are congruent, and these obtuse angles are congruent. These are your opposites. You can draw a diagonal between the opposite angles. Okay, number 4, the fourth fact, consecutive angles are supplementary. Okay, supplementary, what's that, you say? That means they add up to 180 degrees. So, in this parallelogram, if I have my acute angles being 40 degrees, then that means my obtuse angles are 140. This is consecutive right here, one right after the other. Consecutive angles. This angle and this angle are consecutive, and they add up to 180. Okay, so 140 plus 40 equals 180 degrees. Now, our fifth and final fact, diagonals bisect each other. The diagonals of a parallelogram bisect each other. And bisect is a term that we use the very first 6 weeks of school. Bisect means they cut in half. So, we're going to draw us another parallelogram. You're getting good at this now. We're going to draw us a diagonal here. We're going to draw us a diagonal here. And this is where they bisect, so that the longer diagonal is cut in half and the shorter diagonal is also cut in half. So those are 5 parallelogram facts. Every parallelogram has those characteristics. Okay, now we're going to practice some steps. So example 1, math is a parallelogram. Find the values of W, X, Y, and Z. Okay, so here we've got these sides. This side is 15, and it is parallel and congruent to the opposite side. So X must equal 15 as well. Okay, now let's look at these angles. You've got H and M are consecutive. So that means they add up to 180 degrees. So if we want to find angle W, then we know that H, which is 55 degrees, plus W degrees must equal 180. So we subtract 55 from both sides, and W equals 125 degrees. Now, if W equals 125, then the angle diagonal from it is equal to 125. So using that information, we can see that this angle and angle Z are supplementary. They make a linear pair. And we know that all linear pairs add up to 180 degrees. So 125 plus Z degrees also equals 180. Therefore, Z equals 55 degrees. Now, angle Y is opposite angle H, and these two are congruent, and angle T here with angle A, those are also consecutive. So you can see that Y would be equal to 55 degrees. All right, now then, example 2. ABCD is a parallelogram. Diagonals AC and BD intersect at R. So if AR is 5x plus 1 and RC is 3x plus 5, find AC. Find the length of this entire segment. Well, the characteristics of parallelograms say that diagonals bisect each other. Therefore, 5x plus 1 and 3x plus 5 must be set equal to each other because those two segments are equal. So 5x plus 1 is equal to 3x plus 5. And when we go to solve for x, get your x's together on both sides. So we're going to subtract 3x from each side. 2x plus 1 is equal to 5. Now, get my constants equal to, or on the same side, so I'm going to subtract 1. That gives me 2x is equal to 4. And then our last and final step is to divide by 2 so that x is equal to 2. So if x is equal to 2, then we need to substitute 2 in for x. So we've got 5 times 2 plus 1. And I've substituted 2 in for this x. That gives us a total of 11. And if I substitute 2 in for this x, I better get 11 again. And I would. 6 plus 5 is 11. So therefore, AC will be equal to 22 because each of those segments is equal to 11. And we'll put AR here and RC here. All right, that concludes the first part of the notes, and we will start on the second page momentarily.
I would,
No, it stopped.